So let's go and visit our problem of the day and see what we've got lurking there. It says an isosceles trapezoid has a height of 4, bases of 14 and 20. We're looking for area and perimeter. Again, isosceles trapezoid with height of 4, a base of 14 and 20. We're looking for the area and the perimeter. Let's take a look at this problem and see what we're going to do with it. First of all, we know that first part. It says find the area. We know everything we need to know, all right? You say, really? Yes, we do. Let's put some numbers on this picture, by the way. Let's see, I have a 14. We'll put that on the smaller base. That's where we put a base right there. We've got 20. By the way, these are all representing feet, they say. And we have a height. We have a height. Well, you say, well, Ernie, where are you going to put the height? We're going to make it a perpendicular right from this vertex right there, perfectly perpendicular. Well, pretty close to it. There you are. That is pretty perfectly perpendicular. Get that out of my mouth there, all right? And right there's the right angle to say, yes, that would be an altitude. By the way, that number is 4. So now it's easy to find area. Exactly. Yeah, everybody's saying, no, it's easy to find area. You got it. So let's put it over here. How about it? Area equals, by the way, the formula is 1/2 height times the base 1 plus the base 2. Fun and games here. We'll put the numbers in that we need to know. Well, we've got a 4, we've got a 14, and we've got a 20. They all fit beautifully. So let's do it. 1/2 of 4 times our 14 plus your 20. All right, well, that was straightforward enough, wasn't it? Everybody got the right numbers in there at home? All right. Now, 1/2 of 4, let's do it. 1/2 of 4 is 2. And we can add 14 and 20. That's easy. All right, that's going to give us 34. And with that in mind, that gives the area of 68, and that would be square feet. All right, there's your start. So we got the area because we knew everything. So take a look at this problem. Take a look at this problem. The perimeter is a different story. We don't have exactly everything. We've got the 2 bases, but we do not have the legs. But we do know something about those legs. They are congruent, so they will have the same length. So if they're like 8 each, they'll be 8, all right? They might be 5, they might be 4, they might be, who knows? We'll find out what they're going to be. We know it can't be 4 because 4 is a leg. Hypotenuse has to be longer than 4, right? So let's see where we're going to go on this thing. How are we going to figure it out? Well, we're going to do this because it's isosceles. We're going to drop another altitude right over here. And yeah, another right triangle. They kind of look alike, don't they? Actually, they are. They're congruent because this is also a 4 right there. So we've got a good old thing called hypotenuse leg that is going to make those triangles congruent, all right? You say, what does that have to do with anything? That tells me this little guy right here is as long as this. And that's very important for us because we're trying to figure out what number goes here because it's going to mix with the 4 to get us to whatever we're going to get to here, all right? So hang with me here. Stay with me. We have put a 14 right above here. That 14, by the way, goes from altitude to altitude here. There you are. There you are. That leaves me 6, count it, 6 units to split between the left and the right. So I'm going to put a 3 and a 3 because that's what happens when you split 6, my friends. There you go. You say, where's it leading us? Where's it leading us? It's leading us to this little guy right here. And once we get that little guy right there, we got it over there too. I'll call it X because it's time to do a right triangle Pythagorean theorem moment. It's going to be 3 squared plus 4 squared equals something squared. Now I want to tell you something. Some of you all are working with Pythagorean theorem, have been doing a lot of it in geometry classes. You've done algebra classes. Some of these things you should be recognizing. This is a 3, 4, and it's called a 5. It's a triple, but I'm going to prove to you, I'm going to show you, yeah, you're going to get 5 out of this. This is going to be 9 plus 16 equals x squared. It gives me 25, and I've got an x squared hanging on there. Square root of 25, square root of x squared. Well, guess what? X equals 5. So that's a 5. This is a 5 because they're congruent triangles. Their hypotenuse, they are the same, all right? It's a 3 squared, 4 squared, gets a 5 squared, all right? It's triple, all sorts of different things we can do. So now let's take our numbers. By the way, this 20 goes all the way, encompasses that 3. You're not adding 3 and 3 to 20. You're actually keeping 20 as your base for the perimeter. So the perimeter, I see 14 plus 5, goodness, plus 20 plus 5. That's your perimeter, folks. That's your perimeter. We'll add the numbers up. That'll be sweet and easy. I hope it will be. 5 and 5, we got 10. 10 plus 20 gets us to 30, and then 14 more, I'm seeing 44. And by the way, that is feet, not square feet, but just feet for the perimeter. Pretty cool. Easy, and every one of you can do that. You can do that. But the key thing is dropping those altitudes, and it only works, by the way, only this can be done when you've got an isosceles trapezoid to find those missing parts in a problem set up like this. So there you go. Good place to start today.